Hi everyone, I am Rajitha, working as Assistant Professor of Artificial Intelligence and Data Science Department in SNS College of Engineering. Today, we're going to see about predictive analytics. Let's move on to the subtopic that is multiple regression. Multiple regression is a cornerstone statistical method in data analysis that helps us understand how multiple independent variables collectively influence a single dependent variable. And the key concept is in multiple regression, the variables play specific roles. The dependent variable denote as y is the primary focus. It is what we seek to predict or explain. In business, it might be sales revenue. In healthcare, it could be blood pressure. In education, student test score. The independent variable are the predictor or input variables that are believed to influence the dependent variable. Assumption of multiple regression. For a multiple regression model to be valid and its result trustworthy, certain assumption must be met. First, linearity assume that the relationship between each independent variable and the dependent variable is linear. This is visually checked using scatter plot or residual plots. Second is independence implies that the residual are not correlated with each other. This can be assessed using the Durbin-Batson statistic. Especially in time series data, the third homoscedasticity requires that the variance of the residual is constant across all levels of the independent variable. Next one is normality of residuals assume that the errors are normally distributed, and the no multicollinearity is implies that the independent variables are not highly correlated with each other. If they are, it becomes difficult to determine the individual effect of each predictor, and it may inflate the variance of coefficient estimate. Uh, Next is predicting house price. Consider the problem of predicting house price based on characteristic like square footage, number of bedrooms, and location rating. In this scenario, the dependent variable is house price, while the independent variables are square footage, number of bedrooms, location rating. The regression equation might look like price 50 plus 0.15 square feet plus 20 into bedrooms plus 30 location. This equation implies the following interpretation. Next is every additional square feet increase the house price rupees 150. Each extra bedroom increases the price by rupees 20,000. Each point increases in the location rate adds rupees 30,000 on 30,000 to the price. Next is interpreting regression coefficient. Regression coefficient are at the core of any multiple regression analysis. Each coefficient tells a story about the relationship between the predictor and the outcome. And the sign of the coefficient indicates the direction of the relationship, and the positive sign implies that as the independent variable increases, the dependent variable also increases, and the negative sign suggests an inverse relationship. The magnitude of the coefficient indicate the strength of the influences, and statistical significance of each coefficient is evaluated using p-values. The evaluating model fit is assessing how well a multiple regression model perform is essential. This is where model fit metrics comes into play. The R squared value indicate the proportion of variance in the independent variable explained by the predictor. For example, if R square is 0.75, it means 75% of the variance in house prices is accounted for by square footage, bedrooms and location, while R square provides an intuitive measure of model strength. It can be inflated by adding more variables, even those with minimal relevance. To address this, we use adjusted R squared, which adjusts for the number of predictor and gives a more accurate measure of fit. Another critical statistic is the F statistic, which tests whether the regression model as a whole is statistically significant, and the F value with the low P value indicate that the model provides a better fit than a model with no predictor. Together, these metrics helps determine whether the model is useful and whether it generalizes well to new data. Strong model fit support confident decision making and reliable forecasting. Weak model fit may suggest omitted variables, multicollinearity, or structural misspecification that need corrections. And the next is common challenges and solution. It is multicollinearity, normality, non-reality, non-linearity, and outliers. These are the common challenges are meaningful and robust in practices. And conclusion is, in summary, multiple regression is a versatile and essential tool for analyzing complex relationships. It helps predict outcomes, uncover significant variables, and interpret their effect with precision. However, proper application requires understanding the assumption, checking model diagnostic, interpreting coefficient wisely, and ensuring the model fits well. With these components in place, multiple regression becomes a gateway to meaningful insights, strategic forecasting, and data-driven decision making, whether applied in academics, healthcare, finance, or public policy. This method empowers users to make informed conclusion grounded in real data. Thank you.